All right. Okay, I hope you're seeing my screen. Perfect.
Yes.
All right. So yeah, this is the first of a series of presentations about possible ngEHT sites, and I'm going to present the case for installing a new ngEHT antenna in the Canary Islands. Most of the material that I'm going to present in this talk actually had been taken from a recent paper published this year by Alex Raymond and collaborators, with an analysis of the quality of the possible new ngEHT sites, and all the information related to the observatories in the Canary Islands had been very kindly provided by José Alberto Rubinho, Victor González, and Jorge Goya. So all the credit to the material presented in this talk should go to them and to Alex. So Canary Islands, this is actually the largest European observatory. It has two different installations in two different islands. There is one observatory which is called the Observatory Roque de los Muchachos, which is located in the island of La Palma, and a second observatory, Observatorio del Teide, which is located on the island of Tenerife. These two observatories actually contain more than 60 telescopes and instruments from more than 60 different institutions worldwide, and from more than 20 different countries. As I mentioned, this is the largest collection of optical and near-infrared telescopes within the European Union, and it's going to be also the site for new instruments operating on different, different spectra. For instance, CTA North is going to be, it's actually being installed in the Observatory of Roque de los Muchachos in La Palma. And the excellent astronomical quality of the sky in the Canary Islands is actually protected by Spanish law. These observatories are actually something like an astronomy reserve, and has been opened by Spain to all international partners since the establishment of the observatory in 1979, sorry. And the idea is to locate one of these new ngEHT antennas in the observatory of del Teide in Tenerife. The site is at an altitude of 2,400 meters. And it is well tested for astronomical observations for more than 30 years, of course. It has a very stable atmosphere, and the inversion layer is 80% of the time below the observatory head. And the median precipitable water vapor, PWV, as we will see in a minute, is 3.5 millimeter, but 1/3 of the time is actually below 2 millimeter. And it has, it's a site with a long history of CMB experiments since the mid-80s. And actually, this is a collection of previous experiments working at centimeter and millimeter wavelengths that were placed in the Teide Observatory. And you can see here different experiments observing from 10 gigahertz all the way to 230 and 270 gigahertz. So it has been used before for millimeter observations. And it's also the site where new instruments working on these millimeter wavelengths are going to be installed, as is the case for the Groundbird or the ngEHT experiment from the ISC observatory and all the different instruments. So it's definitely an instrument that has been used for millimeter observations. And now let me go to some of the results from Alex's paper. In his paper, he analyzed a bunch of new different possible sites, as shown here. Canary Islands is marked here in this green with this green arrow, and it's of course, it shows up when you try to find what are the driest places for millimeter observations. And Alex used all the MERA2 data to estimate what is the PWV on all these possible different sites. And on the left, you see here the values for current EHT antennas. And on the right, you see different possible northern site And on the top and the rightmost side, you can see here the one corresponding to the Canary Islands in green, and you can see that the PW estimated from MERIT data is actually, very good compared with the current EHT observation, EHT sites. So at least, typical values. And this is also actually in agreement with in situ observations. And below you can see here a plot from Castro and Mansander paper in 2016, where they did this. They measured the PW, the content during 2012 and 2013, and you can see here the actual measure values and the estimated median value of 3.5 millimeters, as I mentioned before, and 1/3 sign below 2 millimeters. But of course, for new ngEHT sites, we would like to have, a standardized way of estimating the quality of the sky in the different new sites. And this is why, CFA has shipped a new radiometer, which has been installed in site, and it's been taking data since May this year. This is a picture of the real radiometer and site. And Alice has very kindly just 3 hours ago sent me some preliminary analysis of the data that is being collected. And you can see here the plot that compares the observatory weather monitor and as well as the new data from the radiometer from the ngEHT monitor. And thanks again to Victor Gonzalez, Jorge Goya, José Alberto Rubinho, and Alex Raymond for installing the radiometer and taking all these measurements and doing the analysis to the data. So the message to take home is that the observatory measurements and those of the new standardized radiometer are quite well in agreement. And this is a good news for the quality of the site. And Alice also estimated some other interesting option, things to learn about the observatory. Of course, we want a observatory which is not cloudy a significant number of nights. And in this case, on the left, you can see the plot that Alex put together with the cloudy days for the current EHT sites and new possible sites. And as you can see, Canary Islands show us up as only very few days are actually.
One minute.
All right, perfect. Okay, so and then let me move to the important thing about the 345 gigahertz capabilities. And as you can see here, the transmittance at this frequency is also relatively good. So it's possible to perform, 345 gigahertz observations in this site. And finally, also, of course, it's very important to check what is the UV coverage provided. And in this plot from Alice, you can see the M87 and site A at 230 and 345 gigahertz observations, and the blue are those baselines to Canary Islands. And you can see that actually, when you check what are the best new antennas to add to the ngEHT, actually, the Canary Islands appears as the second best new site for observations toward M87. It provides also very good, excellent long and short baselines to site A observations. And this is my summary. So I think the message to take home is that it is the largest European observatory. All the infrastructure is there. The quality for millimeter observation has been improved. And the observatory is actually very interested. We discussed it with the director of the observatory, Vikram, and he is very supportive for installing the new antenna, and he is also the observatory is willing to share the cost of installing this antenna. So we are now in the process of gathering the funding, and there is also support from all the institutions in Spain working in radio astronomy, and of course also this significant interest from the institutions both in Europe and in the US to participate in this. So this is all I had to say. Thank you very much.
Thank you very much, Jose. How about if we do all three talks and have the discussion then? I imagine it's a comparative study of these, but while Vikram is setting up, maybe we could entertain one question. But Vikram, please set up.
Sure thing.
Wait, are you trying to still ask a question, or was that from before? Okay, thanks. Okay, great. Why don't we go ahead with Vikram Ravi, who's going to do the next site talk.
Awesome. Thanks. And thanks for having me give this talk. It's great to be able to present some of the activities underway at OVRO over the last little while and our plans for the coming few years. And so this is an update. Mainly I should emphasize on behalf of the Caltech OVRO team, and I want to especially emphasize James Lamb, Dave Woody, and Mark Hodges on site at OVRO, who have been playing a major role in the preparation and planning. So OVRO itself is the Owens Valley Radio Observatory. It is located in the Owens Valley in California. I'm sitting here in Pasadena, and OVRO is somewhere between 3.5 to 4 hours drive north, which makes it very accessible. It sits on a flat plain at about 1,200 meter elevation in a valley between mountains that are a lot higher. It is, of course, the long-term radio observatory of the Caltech Astronomy Department, and the current director is Professor Greg Hallinan. As many of you will know, it has hosted multiple iterations of millimeter arrays. The 10.4 meter dishes, the Leighton dishes formed the OVRO millimeter array, and were then moved up to a high site as part of the Karma telescope. We currently maintain a staff of 15 engineers, scientists, and technicians at the site, but support site activities with campus labs that cover mainly receiver development as well as software. So just to give you an idea of what's happening on site, because for many of you, it might have been a while since you've heard from us. Things have changed a lot since the shutdown of Karma in 2015. We've diversified quite a bit, mainly into lower frequencies. And so we, for example, host things like the Owens Valley Long Wavelength Array, which is an array of 352 dipoles to perform all-sky imaging between 30 and 88 megahertz. There's a solar array, which has been constructed over a long time, led by the New Jersey Institute of Technology. One of the 10-meter dishes is being used for a CO intensity mapping experiment at redshifts 3 and above with a 19-beam spectral line receiver. There is the Deep Synoptic Array, which is an array of 110 4.65 meter dishes for fast radio burst, surge, and localization. We host a VLBA station, barely pictured over there, as well as a 40-meter dish, primarily for AGN monitoring, led by Tony Reedhead. And then, of course, we have the remainder of the 10-meter dishes, one of which is committed to the ngEHT, and a couple of others are being used for a time domain millimeter experiment called Sprightly. So the other thing is that our major plans for the coming few years are to continue to expand our sort of concept of large N, small d arrays into this thing called the DSA 2000, which we propose as a radio survey camera and multi-messenger machine for the coming few years. And you can sort of see here where it sits in the landscape of gigahertz frequency radio telescopes. This is a 0.7 to 2 gigahertz array of 2,000 dishes at a site that will be a few hours travel from OVRO itself. And it will be sort of what we hope the major sort of project that supports the remainder of the observatory into the coming future. That said, we now have a renewed focus on millimeter projects, especially given the completion of the construction on our large existing projects, including the long wavelength array and the deep synoptic array, which we expect to conclude in the coming few months. We intend to refocus on the following two projects, both with the 10-meter dishes, the ngEHT, as well as Sprightly. And so our plans for the ngEHT are to deploy one 10.4 meter dish with an LMT, with the existing LMT 230 gigahertz receiver, plus a next generation digital backend. This will be supported by Sprightly, which will enable interferometric pointing of this dish. And so just to summarize what we hope to be doing, OVRO is intended to serve as, first of all, a test baseline for new LMT capabilities, including a new LMT receiver, as well as potentially other upgrades like improvements to the thermal stability and potentially even testing daytime observing. It's also intended as a test bed for certain ngEHT developments. Whatever requires such a test bed, we're very happy to support, including, for example, monitor and control, as well as a next generation of backend. And into the future, we hope that OVRO will serve as an EHT site that fills in short spacings as well. And so we intend a deliberate sort of progression of tasks to bring up one of these antennas over the coming 2 years, with the aim of being operational in early 2024. And we also anticipate that OVRO can play a role as a base for future sites, especially in the nearby White Mountains. And I'll mention that this effort is funded through the ngEHT MSRI award over the coming few years. And so the current status is that we've done a selection, a grab bag of preparatory work, including we have infrastructure prepared to receive the back end, laid some fiber from one of these antennas to the computer room, which sits in the basement of this building in the background there. We're evaluating the suitability of the maser at the local VLBA station for ngEHT operations and EHT operations. And this maser was actually replaced in the last year. And there is a fiber that runs from the VLBA station to our correlated room. And we're evaluating the quality of the reference signal that we see on the fiber. Then we've also commenced work to refurbish the antenna drives. These are, of course, in some cases, decades-old antennas. Our motors have brushes, and so we're both figuring out, we're figuring out whether brushless motors that we can commercially buy are appropriate. We've cooled the existing 100 and 230 gigahertz receivers to perform initial tests, such as, for example, pointing. And we've also completed a single baseline 8 gigahertz bandwidth correlator to enable that pointing. And so I just want to summarize with this, which is that although OVRO has changed a lot since 2015, both substantial heritage and interest remains at higher frequencies. We are beginning to ramp up our efforts on the ngEHT and millimeter wavelengths more broadly. And we're very happy and committed to serve as an ngEHT testbed plus an EHT site from 2024 onwards. And happy to field any questions. Thanks.
Thank you very much, Vikram. Let's have Guillermo set up. If there's a quick question, there's one in the chat for all three of you, which everybody can answer. But for now, let's have Guillermo set up, please. Let's see, are you there? Well, on the participants, I'm not seeing Guillermo listed. So if any of the local organizers know what's going on with that, please let us know. But for now, let's have questions for the first two speakers. So Marshall, you had a question for everybody. How about you go ahead?
Yes, I just asked about the, whether they plan to have an NG-VLA antenna there or in discussions to do that. And for that matter, a Vigos antenna, just for completeness.
I'll quickly mention that in principle, the first NG-VLA antenna, the prototype antenna that I believe is funded, is intended to be shipped to OVRO after it's been evaluated. And so we anticipate receiving that in something like 5 years. It's currently committed for a next generation of the CO intensity mapping program. However, certainly, if there are other uses, I'm sure we could find a way to do that. Not a Vigos antenna. We don't have any plans on those lines.
Yeah, well, what I'm really asking about is, of course, multiple arrays with co-located antennas. might be useful for certain things, like
I
astronomy.
strongly agree, and we'd be certainly happy to have our other 10-meter antennas used for that.
Great, thanks. So my schedule says Guillermo Blanc for representing Las Campanas site. Is anybody here to represent that site? Okay, well, I guess we'll just continue with the discussion of the 3 talks of this session. Some of it got cut off after Torsten's talk. Are there any more questions about sites while we are here? I'm not seeing any raised hands at the moment. Which actually, puts us pretty well on time despite ourselves. So we can
I
go.
ask a question then?
Please go for it. Yes, Marshall, or?
I thought that to get up to 320 gigahertz, you really needed to have a good, very dry site. And so would, and that implies sort of high altitude, would OVRO, or for that matter, the Canary Islands, be such a site? I mean, has that weather data been analyzed and so on to say how often could you observe at that high frequency?
Is Alex Raymond on the call? Do you want to comment on that? Alex did a weather study, or Vikram, of course.
I'd be happy to just quickly comment. I think
Alex, you may want to comment on this perhaps, since you prepared this slide.
Sure, thank you, Jose. I think this plot is just indicating that within the range that you would have in the months shown, which the shaded regions are bounds for 25th and 75th percentiles. The Canary Islands would be fairly comparable to the SMT in Arizona, which is believed to be a 345 capable site. As far as OVRO, I think Vikram can speak more to that. I think one thing that I've been very interested to hear about is some of the phase transfer technologies that might enable detections at sites that wouldn't be traditionally thought of as 345 sites.
Yeah, I would say that, I think certainly we don't anticipate 345 being possible at the moment at OVRO. It's never been tried. But certainly as Alex says, I think phase transfer is something we'd want to consider. But also we hope to also consider nearby much higher sites, not just the valley floor.
Let me add, in lieu of Maria and Richard, who are like sleeping now in Australia, this technology has only been tested on up to 130 gigahertz. We really want to have this test to be done at 230 and maybe higher frequencies to see if it works as expected. So the phase stability decreasing roughly linearly as we expect and so on. So that's a very important thing to do.
I'm sorry, which technology is that?
Phase transfer, the FPT.
Even so, the atmospheric conditions at OVRO could make it quite difficult. I mean, I've observed at OVRO, and I don't think of it as being a 345 gigahertz site. I think of it as being maybe a 1 millimeter site. It certainly has done 1 millimeter. 345, I think, would be a stretch, and it might just cause you more pain than good observing.
345 is going to be a stretch for most of the existing ngEHT antennas, right?
Well, I mean, the Mauna Kea, for example, Apex, Alma, South Pole, even Thule, and Iram and Oima. I mean, these all can do 345 gigahertz, and even the Canary Islands. It depends on what kind of weather you have there, whether you're above the inversion layer, and if you. This is why we've been thinking about 86 gigahertz to bootstrap up from there to 230 and then from 230 to 345. But as Jose pointed out, we've deployed Alex's new water vapor radium or water vapor sensor, and we should know more, quite soon about the prospects there.
With this bootstrapping at 86 gigahertz, I'm only worried that if you use 6-meter antennas, there may be not enough signal on the baselines of those at 86 gigahertz. Well, that's maybe okay for strong sources, but then maybe limited in bootstrapping capabilities. So that's something to consider when one decides on everything, on frequency and then on the diameter of antennas.
Yeah, absolutely. We hope to learn more about that through the study that Sarah and Freek and Dom have been doing.
Okay, great. Sridharan Tirupati, could you?
Sure. Thank you. I have two questions. One just slipped out of Shep's mouth a moment ago. What about the use of 22 gigahertz or 183 gigahertz water vapor monitors for phase correction? Is this something that's been looked at all? That's one question. And the second question is for Jose Gomez, that I have read recently that there are issues about TMT sighting in Canary Islands. Is that restricted only to the TMT? Is that not something that is affecting any possible millimeter telescope? Thanks.
Well, I'll just say a quick word about the PWV monitors. Of course, they're used with ALMA. I mean, all the ALMA dishes have water vapor radiometers that are coaxial with the beam, and that's used to quite good effect. We use it when we use the EHT, and so we could consider using those in the ngEHT dishes. It's something we should consider. I'll let Jose handle the Islands question.
There are no political issues, as I mentioned in the talk. I mean, it's protected by Spanish law. I mean, this is a astronomical facility that since 1979 it's like a astronomical reserve. It's really protected by Spanish law. So there are no restrictions there whatsoever for installing TMT or any other telescope, other than that, interest from the participating parties in installing the instrument on the site.
Okay, wonderful. That's great to hear.
Great. Well, thanks to everyone who participated, all the speakers. First of all, let's unmute and thank them again. Again, thanks to everyone who participated and continue on Slack and in the social session, which I think the other organizers will take over from now.